Okay, Taylor, let's start with you. You said you had some questions. Where do you want to? Oh, okay. No? 10? All right, so number 10 says find the values of the arc cosine of negative zero point 0.8 that are in between 0 and 4 pi. So first question, what mode are we in? Radians. So when you take your calculator and you put it in radians and you go, yep, you go second cosine of was it zero point 0.8 or negative zero point 0.8? Okay, thanks. Then you get 2.498. And then if you look at your notes, you know that you have to, what's that? Plus 2 pi n. Okay, so if I plug in 1 for n, then, oh, I'm sorry, if I plug in 0 for n, then I get my first answer, which is 2.498. If I plug in, what if I do it this way? If I plug in 0, I get 2.498. If I plug in 1, then I get 2 pi plus 2.498, which is what? I'm looking for a calculator answer, not a guess. What do you, or a fruit, right? If you go 2.498 plus 2 pi, what do you get? We get to pick. Yep. Well, that doesn't matter because we didn't do a sine or cosine. Nope. Just doing regular math. 2.498 plus 2 pi. 8.78. Okay, is that less than 4 pi? Okay, yes it is because 4 pi is like 12-ish. 12 point something, and so we're still good there. How about if I plug in 2 for n? So what is 2.498 plus 4 pi? It's not 0 and it's not banana. I don't know. Thank you. 15.06. So that is, yeah, we're definitely over. So that means that our only two solutions are 2.498 and 8.78. Yeah, great question. You can only do n as whole numbers. Yes. Uh-huh. Uh-huh. Okay, when we do the inverse cosine, were we supposed to do plus and minus of it? Okay. Yeah, so, but is cosine plus and, yeah, what was the first? Okay, so why, so we screwed that up because we only did plus 2.498. So we also need to solve x equals negative 2.498 plus, whoops, 2 pi n, right? Cosine's the one that does, sine does not, yeah. Oh, you haven't done addition at all? I see, and so you just assumed then that was for all of them. Right. Okay. But when we did the sine thing, I think the reason that we ended up subtracting is because the answer came out to be negative when you did the inverse sine of that. Does that make sense? But then you still want to add on to that. The, always add, yeah, and it's just a question of whether what you're starting with is positive or negative or both. Okay? All right, so we haven't actually finished this one. So, yeah. Yeah. Okay, so when we plug in 0 for n, we actually get two answers. 2.498 and negative 2.498. Because 1 is when this is positive and 1 is when this is negative. Now when I plug in 1, like we did before, Cody said 2.498 plus 2 pi was, what did you guys write down, 8 point something? 8.78. Okay, but then we also have to plug 1 into n for that one. So what is negative 2.498 plus 2 pi? I want to know exactly. Negative 2.498 plus 2 pi. So we got this answer by going positive 2.498 plus 2 pi. But we also have to go negative 2.498 plus 2 pi. Hold on a sec. What? Because I kind of want to do, thanks Cody, I want to do them all and then cross out the ones that don't. Okay, so now let's plug in 2 again. So when we plugged in 2 into here, 2.498 plus 4 pi was, yeah, 15 point something. Thank you. But if I plug 2 into here, negative 2.498 plus 4 pi is going to be in our range. What is it? And Cody's got it. Or maybe he doesn't. .06. Okay, so now that we have these figured out for n equals 0, 1, and 2, we can cross out the ones that aren't in the range. So this one is no good and this one is no good. So our 4 answers are 2.498, 8.78, 3.79, and 10.06. You don't like that? Okay, I was just trying to organize a little bit. I'm trying to figure out how to, oh, okay. So if we, where these come from is if I change this to be the inverse cosine of x. No, I don't want to mess with that. Okay, do you guys have any other questions from the assignment from Friday? Any other questions from the assignment from Friday? Okay. All right, I'll take those. All right. We can, yeah. Gus, now you're not watching video. Please put your phone away. Okay. Danica, will you put your phone away, please? We're going to have to go back to the up here. You guys are so bad. So tiring. Okay. Okay, so we can make these more complicated, of course, to solve. The ones that you guys did, the 1 through 10, were just a simple second cosine or second sine or second tangent, and then you did the plus or minus stuff. But we can set it up so you have to do a little bit more work before you get there, okay? So for example, if you were asked to solve cosine squared plus sine plus 1 equals 0, what you would try to do in this situation is get everything in terms of either sine or cosine, okay? So do you remember what the identity is that we can use to change cosine squared into something with a sine squared? Well, what's the main one that we... Okay, so we... Awesome. Perfect. Cosine squared plus sine squared equals 1. So that means cosine squared is just like Sky said, 1 minus sine squared. Okay, does that make sense? You guys see where she got that? Okay, so I'm going to rewrite this, but instead of writing cosine squared, I'm going to write 1 minus sine squared. And then plus sine plus 1 still equals 0. How do you guys feel about that? You feel okay about that? Yeah? Alright, then I'm going to combine my like terms. What are like terms that I can combine? Nope, because 1 squared and 1's not. The 1 and the 1 combined. So I can go negative sine squared theta plus sine theta plus 2 equals 0. Okay. Then I would like to not start with a negative. So I'm going to change the sign on all of these. I'm basically going to multiply everything by -1. So the negative sign squared becomes a positive sign squared. The positive sign becomes a negative sign. The +2 becomes a -2. All right? Okay, so all that work was to get it into a form where now I can factor this in order to solve. Okay? So what goes in front of the parentheses so that when I think you multiply it together, I get a sine squared? Sine and sine. -2 plus 1. Okay? Gus, we're teaching class right now, okay? So sine squared minus sine -2 factors into sine -2 times sine plus 1, because -2 times 1 is -2 and -2 plus 1 is -1, right? Okay, so then you remember, I hope, from last year in advanced algebra, that if you have two things that multiply together to equal 0, either this is 0 or this is, whoops, plus 1 is 0. Okay? So if it's the first one that is equal to 0, what does sine of theta have to equal? 2. And if it's the second one that equals 0, what does sine of theta have to equal? -1. So how do you get rid of the sine? How do you solve that for theta? How do I get rid of the sine? How do I solve those for theta? Inverse sine, that's what we've been working on. To get rid of a sine, you have to do the opposite of sine, which is inverse sine. So if I take the inverse sine of this side, the inverse sine and the sine cancel and leave me with theta. And then I have to take the inverse sine of that side also. So what is the inverse sine of 2? Yes, we are in degrees, right? Because it's theta, and it also says, yeah, between -90 and 270, yes. Equals -1. Right. Okay, you got a domain error, because if you think about the graph of the sine function, it goes in between -1 and 1. So it can never equal anything bigger than 1 or less than -1. Okay? So this one is out. Okay? What about this one? You got 90 degrees? Yeah. Okay, what's the inverse sine of -1? -90? Okay. Nope, that's good. That's our answer, -90. Okay? Bowling? Does that make sense? What we just did? Yeah, there's no answer to that. Okay? But the inverse sine of -1 is -90. That's the answer that we're looking for. Okay? What? This one? From here. How did I get this? Oh, okay. So when you're factoring, you want two numbers that multiply together to be this number and add to be that number. So negative 2 times 1 is okay, got it. Okay. All right, so our answer is negative 90. But then when you guys look in your notes, how do you find the other values of sine? Yeah, the arc sine thingy. Is it plus 360 again? Okay, so I could also take this negative 90, and if I add 360 to that, then I would get 270. So this actually has two solutions. That's just a coinkydink. Yep, negative 90 and 270. Well, that's not the answer. They just want the, okay, here's what we're doing. So they started with cosine squared. Essentially, here's what they're saying. They're saying if you take cosine squared, essentially, plus sine, and what was it, plus 1? And we want to know when does that equal 0. So what they're saying to you is, where do these two lines cross? Okay? But they only want to know in between negative 90 and 270 in degrees. Okay? So let's change this to be negative 90 and change this to be 270. Because they said we only want to know what the answers are in between these two things. Okay? Well, and it just turned out that one of them was at, right, one of them was at negative 90 and the other one was at 270. But that's not that they gave us those as answers. They just said only look for answers in that range. Okay? If they'd have said look for answers between negative 90 and 720, then we would have had to add 360 again. So we also would have had 630 as an answer. And then we would have added 360 again and got 990 as an answer. And then we would have been like, oh, that's bigger than 720, so we don't need that one. Well, there weren't any in-betweens in this case. Usually, there was one answer at 2. What's that? But we don't want those dots. We only want where it equals 0. Yeah. Okay? So in this case, the answer turned out to be on the interval. But that's not always going to happen. And if you want to get technical, what do you notice about these brackets? One's square and one's closed, so they don't actually want us to use 270, so really we should throw that one out. Okay? Because it can't equal 270. All right? So there's actually a lot going on there. All right, let's try another one. Oh, okay. Let's see. Some trigonometric equations cannot be solved algebraically. Well, that's fun. Let's not mess with those. I'm sure that they just want us to graph those, and that is so easy a caveman can do it. So let's do some. Anyone? No? Thank you. Who are you texting, Kai? You don't think it could just wait and maybe... Really? I really needed to know. Turn it over so you don't see that thing coming. All right, so we guys get out a piece of paper. Let's try working through some of these together. I have a feeling you're going to have some questions immediately. Yeah, so this is going to be your assignment.
I had questions on the last part we started. You hate toast? What are you talking about, toast?
All right, so your assignment's going to be page 173, 21 through 26. Let's go ahead and work through some of these together, so that there's only one example there, so I'm not quite sure that you have got it yet.
All right. You can stop that, Senor. Senor, keep your class under control. Probably do nothing until you
No, you don't even actually have to do that. Nope. All right, so for number 21, Taylor says, I don't even know how to start. Well, you're trying to get the theta by itself. So I like what you're doing with the squaring thing because there's a square root in there, but it's not the variable that's being square rooted, so we don't really care about that. So how can I get rid of that square root of 3? Seriously, dude? Oh my god. Okay, no, just come on. You can wait. All right, we got class right now. This is the only time we got class. Get a piece of paper. Come on. Okay, well, you say it was my fault. And if they want to send me an email and yell at me or call me and yell at me, then I will take it. But this is our time together. We got to use it. What are you going to do? Yes, subtract the square root of 3 from both sides. And then how do you get rid of the tangent? And then you do the inverse tangent. Yeah. And what mode should we be in? Why? Yeah, theta's degrees plus, Mylena. It says right there 0 degrees to 720 degrees. Okay? So make sure you're in degree mode. Stop errors. And go second tangent, negative square root of 3. Okay, that's fine. So theta equals negative 60 degrees. What? I didn't put the 3 back over there. I subtracted it, and then I needed to get rid of the tangent. So to get rid of the tangent, I took the inverse tangent of both sides. So then those cancel. Okay? No, look in your notes. Right, for tangent it's plus 180. Okay? So negative 60, then I add 180 gives me, because 120. And then if I add 180 again, then I get 300. And then if I add 180 again, 480. And then if I add 180 again, 660. And then if I add 180 again, then I'm past 720. So I don't need to do that. Right? Okay? All right, so I want to show you guys the graph of this again. Make that connection. See how this time it's not 0 and 720. We just want the answer to be in between 0 and 720. So what this one is doing is it's starting out with the tangent of x, I'll just use x, plus the square root of 3. And we want to know where does that equal 0. In other words, where do these lines cross? And so our first answer was 120, right? And then the next answer was 300. And the next answer was 480. Okay, so that's where the graph is crossing the line. Y equals 0. Are you on the next one? No. It stays as normal, okay? All right, so Sky, being the outstanding student that she is, just jumped right on to the next one. Nice job, way to work independently. So the first thing you did was what? Minus the square root of 3. Divide by 2. Okay? And then how do I get rid of the cosine? Yeah, you inverse cosine both sides. So I'm going to inverse cosine here, and I'm going to inverse cosine there. Those cancel. So theta equals the inverse cosine of negative root 3 over 2, which equals, now remember with cosine it's a plus minus, right? You got 150? Okay, and the inverse cosine is plus minus, right? So you have to go plus or minus 150 plus 360. Okay? So plus 150, I'll do this without making the table this time, Sky, because that bugged you. So plus 150 is our first answer when I made the table. Negative 150 is no good because that's less than 0. Okay? From right there. Second cosine, she got 150. So that's my first, right, of negative root 3 over 2. So that was my first answer. Okay? Then I'm going to add 360 onto that. What do you get? 510. But then I also have to add 360 onto negative 150. So that's 210. And then I have to add 720 onto 150. But can you see that that's going to be bigger than 720, so we don't actually have to do that? Okay. Then if I go 720 onto negative 150, that's going to be in our neighborhood. 570. Okay, so those are our 4 answers. Okay? Okay, one more together, and then you guys can do the last 3 by yourselves, you think? Yeah? Okay. Oh, that's kind of weird. What's the first step? Nope, because it's divide by 2. Yeah, it's the sign of that. It's not the sign times that. So we're not distributing. We're dividing by 2. Okay, then what? Yep, then I have to get rid of the sign, so I'm going to do the inverse sign of both sides. So these cancel. So theta plus 470 equals, what's the inverse sign of 1/2? And then, yep, and then subtract 47. Nice job, Janess. So it's minus 17 degrees. Okay. And then how do I find the other answers if there are any of them? I have to add 360 onto this, yeah. Yeah, good question. Because the graphs look different, so they have to do different things to them to get them to be functions. We put that in our notes on Friday. Do you want me to put that back up on the... Were you gone on Friday? Okay. Let's just finish this real quick. If you add 360, then you get 343. So that's our other answer there, okay? All right, do you guys think you can take the last 3 on your own? Yeah? Okay. And I'm going to get the notes back up there for Janessa because she was gone on Friday and is understandably confused. I hope so, yeah. I'm trying to charge it now. So, Janessa, there's the nonsense for sine. We did cosine already, but they put that back on there anyway. So those are how you figure out the other things, okay? Okay?